Hi there, my name's Jeremy Stewart. In this presentation, we'll be going over joins in SQL queries. These are very similar to the kinds of joins that exist in relational algebra, so if you've seen those, it'll be very familiar to you, but if you didn't understand how those worked or found them difficult to comprehend, this should help you out. If you haven't seen relational algebra at all, this will be a good primer for how that works eventually, if you do see it. Just a bit of an overview. I'll give you an example of some data, and then we'll go over inner joins, left and right outer joins, and then full joins, with a final explanation of why you would use these in the first place. Just a note that all the queries written for this presentation are for MySQL 8.0. They might not work for earlier versions of MySQL, and they might not work for other versions of SQL. So this is an example of the data that we'll be using. We've got two tables. One lists a person, there's their names, and person ID will be their primary key. And then there's a table of likes. It uses their primary key to list their corresponding like. The question is, how do we combine these two and find out who likes what? And to do that, we can use joins. So first is inner joins. This is all records that match from each table, and formally said it's the set of records that match in both tables. And this is similar to the equijoin that you might have seen in relational algebra. So the inner join query is going to look like this. In this case, we're going to select star, which will select all columns. From person is A, which means we can refer to the person table as a variable A. And then we inner join likes as B, so likes can be equal to B. And then we say on A.personID equals B.personID. So A will be the table name, in this case person, but we can refer to it as A. And then .personID will tell us which column. So this is where person IDs will match from person and likes. So getting ready to do our join, we notice that Darwin and Elizabeth don't have any likes in this table, so they will get dropped entirely. We'll switch these two columns around so it's easy to see what it looks like, and then we drop Darwin and Elizabeth. Now we start merging our two tables. So we're selecting all the columns so they move over. We notice that Patrick likes baking, but Patrick also likes football. So these values will move down, and Patrick also gets another entry. So Patrick will have two entries listing two different likes in the resulting table. Albert likes music, Maria likes cycling, Alexi, she likes programming, and then we notice that Martha likes cats and Mara likes more cats, and that's the resulting table that we get. So this is our inner join from the person and likes tables, where the person ID is equal on both sides. Again, if we switch them back, those are the two tables. We take out the people that don't have any corresponding values over here. If we had any likes that didn't have a corresponding person, like if there was a 9 here instead of a 7, and there was no 9 on this side, then that value would get dropped, but that's not the case here. All of these values have people that correspond to them. Just for visual, we'll shuffle that, and then we merge them together, and that's our resulting table. Now, this is a little confusing because we have person ID twice, and we know that both of these values are going to be the same in both columns. So what we're going to do is we're going to change our query. We're going to select name, and then A.personID and likes. Remember, A is person, so this is person.personID, which means we're just going to select this column in the resulting query, not both columns. When we do that, it looks like this. This is much cleaner. We can do queries on this and it won't be confused about which person ID column it wants to choose. So remember, that's all the values from both tables. Each of these circle is a table for which certain values match, and this is the result. This is what it looks like. Now for left joins. In a left join, it's also referred to as a left outer join. You'll hear people call it that sometimes. And this is all records in the left table and the records that match in the right table, otherwise the value is null. And this is the same as a left outer join in relational algebra. So what does this look like? Well, let's say we have these two tables. I've modified them a little bit. Here's our query. We're going to select name. We're going to select person.personID. Notice we're not using A.personID here because we've just said from person. We haven't said that we're going to call person A. That's not a variable name. So we have to use person.personID. And we're taking likes. And then we say from person left join likes. So what's going to happen is we'll keep everything in the left table in a left join, even if there's no corresponding value. So last time we took out Elizabeth and Darwin because they didn't have any entries in like. In this case, they're going to get kept. Everything in the left table gets kept no matter what. And those will line up with the likes. So again, likes go, and they find their corresponding entries for person ID in the person table, but now we've got empty spaces, and the question is, what happens to those? Well, that's where that null value comes in. Those null values get added in. So Darwin and Elizabeth, their likes are listed as null. So what we've done is we've kept everything in the left table, even if there was no corresponding entry, and we've matched it up. And you can remember how this works because in our statement, we have here from person left join likes. The left is going to be the thing that comes on the left side of the join statement. So in this case, person is going to be the left thing. So person is all the values that get kept no matter what. The right join is similar, also called a right outer join. All records in the right table and the records that match in the left table, otherwise null. So this is the same as the right outer join in relational algebra. We've changed the data around a little bit, so our query just has right join. So in this case, we do drop some people's names. Because remember, it's a right join, so the right table is likes here. So the right table is going to keep everything. If there's values in the left table that don't correspond, those values get dropped. So Albert, Darwin, and Elizabeth get dropped. We'll move these values up. And then this happens. So the names in the person table will find corresponding values in the likes table. We notice here that Martha has 2 likes, so she gets added twice, and then barbecue was listed as a like for person ID 9, but there was no name with person ID 9. So that gets a value of null in this case. And that's the result of our right join. Remember, we kept everything in the likes table, no matter what, and we match everything in the person table, and if there is no match, then we give it the null value. It's the same thing we did last time with the left join, just in this case, we keep the right table, which was likes. And again, in the query, you keep the thing on the right side of the join. In this case, it was likes. So a full join. A full join is also called a full outer join. This is all records in both tables, whether there is a match or not. It's the same as a full outer join in relational algebra. So just as a warning, in MySQL, full joins are not supported. You have to do a left join and a right join and then union those two things together. That'll be the equivalent of a full join. So don't try to type this in. You'll get errors. You'd have to do a left and a right and union those two things together. But let's just show what a full join does. In this case, we have a similar example. We do the full join instead of left or right. And what this is going to do is it's going to line up all the person IDs for both and then fill in any empty values with null. In this case, we've taken everything from both tables, lined them up, and if there's no corresponding entry, we've made it null. So that's how a full join works. So why would you use a left, right, or full join? Well, you'd want to find examples where there's no corresponding entries from one table to the other. So as an example, we did find all people who don't have a like. Let's say it results in this table down here. We did a left join with person. So we keep everything in person, and then we find their corresponding likes by person ID, and then put nulls in where there's no like. And then we can select the name where the like is null. So we select all the names over here where the value for likes is equal to null. And what does that tell us? This tells us that Darwin and Elizabeth don't like anything. And why would we want to know that? There's other ways of doing it, but this can tell us all the people who don't have a like. And it can also tell us other things. Maybe there's something wrong with our data. Maybe everyone is supposed to have a like, but in this case they don't. That means that maybe Darwin and Elizabeth somehow were able to put their data in without entering a like. Maybe there's something wrong with the way that our data is being generated. Maybe there's something wrong with our table. So we can find any errors or values that are off in our table this way. So some useful resources for you. This is called Visual Join. This is a website where you can select the type of join. It'll give you an example of what the SQL statement looks like, and it has some data down at the bottom and shows you how they line up. This site I really like, SQL Visual Join. This is by a guy named Alexei Vasilyev. You select which parts of the two sets that you want, and it'll show you what the corresponding SQL query is, and then you can copy it out and change it. So this shows you what those SQL queries look like. So this is good for translating what you know into the actual programming of SQL. So thank you for following along with this presentation. I hope this helps you out. Inner joins, outer joins, they can be a little confusing sometimes. Hopefully by visualizing them here, you get better at being able to combine tables and find the data that you want. Thanks for following along.